an idea, but
Yeah.
maybe it's not possible or you don't want to do it. But uh, you know, we use the address sanitizer.
Yep.
Like we don't have to, but it's suggested, and like it's something that's not easy to understand at first, and yep, maybe I should take the time to really learn how to use it really well. But if you could give us just a primer on it, if you think it's interesting, I would like that. But
Yeah, I like this one. I will take it.
okay,
Um, so many times when I use so I at my time I didn't use F Sanitize. We used something. It was a separate software called Valgrind, open source, and now it's I don't think we can still compile it because of 32 to 64 bytes. So first time I've used it, I like had like many screens uh, of mistake, and I was like, okay, let's take a look. So I look at that line and I look at it and I'm like, no, my ground is wrong. You know, it's not possible. And each time, so each time he was right. So why why is that confusion? Why I was saying like, oh, it's wrong because on that line I wasn't doing any mistake. It just because of something that happened before I was wrong. So we'll go through it and see why. um, I feel when you start to be good with Sanitize, it's kind of the last level in C. When you don't need it, when you know, like, oh, I haven't done any mistake, or I know what will happen. It's really well, like, oh, okay, you reach a level of, where each memory cell has been allocated and etc. And this is where I want you to be. You need to be there uh, because when you will be, um, I'm trying to find another word that said, you will see like a super master of or super expert in C. When you arrive to the code of someone and you look at it and you'll be like, yeah, it's because you haven't allocated. You should do +1 here. And people will look at him, how does he know? And yeah, it's kind of fun. Um, so yeah, let's do that. My screen. Do you see my screen? It's loading. Yep. We'll move that here. Um, the memory. I already have a memory. Let's delete everything. Touch main. So let's start simple. I think I will just RM everything one day. I have too much thing. So let's start simple. Okay. So I have a main. I will do jcc.o main. For this time, I won't compile it with make, like the lazy. I'm doing it every time. So what is fsanitize? Here it compile, everything is happy. Fsanitize memory. So, I think it's like that with a dash being, yeah, Stack Overflow call. Uh, which one are you using? Address or memory?
let me see.
I think it's address.
Yeah,
Okay, because memory seems to unrecognized. So address, cool. So here, let's just make it run. Nothing wrong. Pretty cool. So how does it work? So I will do. I will create. Hope you won't say fault. So alright. So I create a pointer which point on null, and I will go to our address 1 for the null declaration. So here, obviously, it should say false. Let's see. That's in compile, but we have a seg fault. Let's compile without it. Default. Why? It's because I'm going to null, which is 0. I'm going to the address 0 in memory, and I'm trying to insert 1. So, but address 0 is already taken and very watched. So that's why it's creating a segmentation fault. But let's take another one. Something I'm starting at 0 and plus that index, and this one should work. No, it's not working. Let's try to go more. Let's try to declare a variable in order to have an address, and here I will cast it to an int. Oh, still seg fault. Anyway, okay, so this is like seg fault. That memory doesn't belong to me, and I'm messing around with it, so it crashed. This is like easy case. Let's go for another one that is not easy. So like char star array, and I will malloc one cell of memory. So this thing, it's a char. Let's keep it like that, but you know, we can still put 1. Okay, so here it should be correct. Just the lib. Yep, so it's correct, but I haven't freed, and it's what it's telling me. So detected memory leaks. Cool. It's what happened because I've malloced, but without freeing. One thing that you need to see is freeing at the end of the software. It's kind of a performance issue because anyway, when your software is finished, the shell will get back the memory. So you don't need to do it, but you must do it right now. Why I'm saying that? Because you need to be in control of your software. I want you to be like, okay, so I can free everything, and I command the function in order to be faster. Because before being able to say like, oh yeah, I don't need to do it at the end. Let's make sure that you are able to do it. So if I free array right now, we don't have that memory leak anymore. First, I wanted to show you something. So it's amazing. It's telling us that we have one malloc that hasn't been freed, but it's kind of complicated. So it seems to be. So this is a call stack, all the different function. First function in C, and you can actually overwrite it. It's start. So this is the first function that is called, and then it's calling the main. So it's why you can see that thing first. Then you have the main, then you have the malloc, but it's annoying. We don't see a lot. So in order to provide more debug, we use the flag G3, and we will have more information. Okay, it might not be like, oh, mind-blowing, but it's pretty cool. here, that little 7 that appeared, it should tell you which line the malloc happened. So it's here. When your code starts to be longer, it's really helpful to have the line of the call stack. So G3, pretty cool. Then let's free. In order to remove it, we don't have it anymore. Okay, so we've allocated 1 of memory. So let's go here. If we follow the logic of earlier, it should take 4. That memory size doesn't belong to me. But we can see that, let's remove this one. It's not segfaulting. Should, but it's not. Let's see what fsanitize is telling us. It's telling us a lot of things. What is important here is heap buffer overflow, which means that you access memory that doesn't belong to you. You went too far. Here is located at 0 byte, blah blah blah, and how much how much like you. So we just like went for 1 byte. And same thing, so the malloc, which line, and this one will be where it happened. So it's line 9, you can see the 9, and it's here. It will tell you like, hey, you went too far in memory from 1 on line 1. Yep, so why that thing is complicated is you will have, so this is a write here. Do something like that. And we will do A and \0. And print string.h. And after I will printf the size of my string. And I'm using strlen. Let's choose my strlen. All right. Let's put strlen. Okay. So let's see what is happening. One thing that is missing here, I'm allocating for the size of A, which is 1, but I haven't allocated for this one. Like very often we do that. So, +1 here, and we should actually respect the math. But I'm not doing it, like I forgot. So let's compile. Yep. So it's yelling at me, and it's telling me that I haven't have like an overflow, and that overflow, I think it will tell me right away. Okay, so it's line 20. So it's not exactly what I wanted to show you, because what I wanted to show you is that sometimes it's triggered inside another function. It will be here, this one, line 10. You have like, hey, I'm going too far. Or maybe let's do this one. This one should trigger it as well. Yep, cool. So it triggered it. So I've done 2 mistakes here. First one is I didn't put the +1, and I haven't initialized the end of my string, by a \0. So my code works. I'm pretty sure, if I'm supposed to print something, it would work. But sometimes it will crash because here I'm reading one too much in memory, and I'm supposing that memory is filled of 0. So first time it will work. Then second, if you are using a memory that has already been filled with other thing, it won't work. Here, it will tell you line 10. Like very often, I tell you like write a simple line of code because when you will arrive with fsanitize, and what fsanitize will tell you like, oh, it's line 10. Yeah, it's pretty obvious. It's not it's not the \0 that is wrong. It's clearly here. But if you have a y with something like that, oops. Something more complicated, but you don't know which one is wrong. Maybe, if you have like a +1, when you do something more complicated, you don't know which one is wrong, and this is why I kind of have that rule of one line, one thing, because when you will need to debug, but you don't know which one is wrong, so it's longer, harder, etc. Yep. What else? Let's do another mistake. This one here. I hope you will trigger. Let's fix the code first. +1. All right. Yeah, that works. Let's not initialize
the question. So when
It
I
should tell us if it's not initialized.
it's you have a string and you need to validate.
Flags. That's weird that this one is not working. Thanks, I think. That's better. So welcome to multiple compiler. So it's a new world. First time it happened to me, compiler was called CC, done by Intel, and it was pretty cool, because you type 2 characters and like bam. Then other people from the new corporation arrived with like a way better compiler, and when I'm saying way better, it's a compilation. All the warnings that was raised. So I started to use GCC, and I was so happy. When it tell you like, oh, you have done a mistake here, etc. You are very happy. Now, Silong has been developed mainly by Apple. I can actually explain why. It's still open source, and when I'm saying developed by Apple, it's just Apple providing a lot of resources to develop it. And Silong is really, really cool. You can see, it's just completing the code for you. So yeah, it's telling me right away without any flags. I think I will, I will go back on the code compilation, and I will remove GSSA and do an alias on Silong. But I'm not sure, because on the other way, I kind of like you to discover, oh, Silong is better, and starting to talk trash to people who are using GCC. So today, on my computer, when I'm doing C, I'm using Silong, because as you can see, so here he quotes the mistake of not initializing the variable. For sure, at the beginning, it might be 0, but we don't know that that's exactly the problem. We can do that, and oh, it's crashing. We have a seg fault in my strlen. No, just because you haven't initialized it. So I've done really simple cases. When you start to have like a linked list, and you allocate a char star inside it, to free that linked list can be a pain. Really, kind of the rules is so. Yeah, and when it's not necessarily you that have allocated it, but if you use like strjump, it's doing an allocation, so you've coded it. So I will have a leak here because I haven't freed. Yep, leak detected from strjump, so I need to free S as well. Yep. Question, hope it was clear.
Yeah, thank you. I don't know if we have time, maybe not, but I would have liked to know more about sometimes you get presented like a big table of addresses, and it says something like, here is the buggy address, and so you have this table of hexadecimal numbers. So this is what I had not the courage to try to figure out yet. But
no, let's try. But I'm not fluent in Hexa anymore. I used to be. I removed the plus one here. So you are talking about this one here.
Yeah, I just don't know how to use that exactly, or maybe I don't know if it's really useful for what we're doing. But
to be honest, no. Because what you're doing is, I would say, like simple, and you have full control of your software. When it's very useful, it's like, for example, here we have a core dump. Let's jump on. When you seg fault, it generates a file. So it's called a core dump. What is a core dump? Is your memory fully done. Like, oh, you have done something wrong in memory, so it's either abort the seg fault or kill or anything. It will generate that file, and that file is just your memory that has been done. And when you look at it, it looks more like that. In order to read it, you need to use the command hexdump. So it will dump what is inside in hexadecimal. Any of them. And you can see on the left you have the memory address range and what is inside. So we can see on this address here, we have a 43, 49, but beginning of the software, all this party is my software. After, I don't know where the pointer on the stack starts, but it should be around, I guess, here. And actually, you can see like most of the time, like memory, is full of zero, but sometimes it's not. um, yeah, here you can see a lot of, but this one, for example, you have a one. So you're right, your index, yeah, well, actually is one. So yep, and if you go back to this one, it's a simpler, it's simpler. It's just like the memory we are right now, and so it's in hexa. So FA in hexa, so it's 250 core, and we have one, or one, maybe it's A. No, it's so yeah, I cannot really read it, but yeah, it's your memory, so it's where it happened, and let's try to play with it. So I will replace A with B, and we'll see. We'll open a new tab. So here it's a good example of me not knowing how to use it. And like I'm really taking a baby step. I've put A and B. Well, I know that there is a one difference, and I will try to just see what is the difference between this one and this one. But actually, there is a legend here. So you have the stack seems to be FA. Hmm. uh, where is my display? Oh yeah, not in the right spot. Memory. So also that thing, it happened to me so many times. I'm compiling in the wrong software. So I compile and I'm not editing the correct file. So always ask yourself, like, hey, why? Uh, how over the year what I'm doing is what I'm expecting. Here I was expecting to have that, and if I don't have that, there is something wrong. And it's not, oh, something is weird. No, it's like I've done something wrong. So if we compare here those two one, I don't see a lot of difference. Actually, I really don't see any differences. So let's go lower. Oh, it's exactly the same. Okay, so I will tell you that I don't know. Well, question is when will you need it? Is I need to be able to read like memory and core dump, etc. It's when you work on kernel or application and you have a client. You start to send your application everywhere, and it's coded in C or something like that, and your client, they won't, you can't do like, hey, wait, hello, can you put a printf in the code, and we're compiling it. So they will send you the core dump, and from the core dump, you will use like either a software, a debugger, or something like that, in order to be able to resimulate what happened, and it's kind of giving you clues, but here you need to be a very good investigator, because it's like arriving to a murder scene, but you don't know that before an asteroid came, and I was scared. So it's hard to see all those things. Yeah, video games mostly it's where I call them are really used because it's either coded in C or C++, and yeah. Otherwise, people are telling you like, have you rebooted? Cool. Hope it was helpful. Definitely So it's really on my scale. When you're good with F sanitize, it's where you're good in team. Cool. So time to eat. Happy to see you. Cheers.